Hello, my name is Makwana Bhavin and I am your today's instructor for computer network practicals. So what we are going to do today is we are going to look at the Wireshark. So what is Wireshark? Wireshark is basically a tool that will help you to capture the data or the packets that we are sending while we are connected to internet or LAN or any another kind of networks. So for first, what you have to do is you have to go to the wireshark.org, and from that you have to download the Wireshark application setup. So depending on your OS, you can download the setup. Mine is Windows 64-bit Windows 10, so I will install this one. And as you can see, it is also available for the Mac OS and the source code older stable release, and you can choose whatever the version of Wireshark. For my preference, I am using the latest Wireshark version of it. So let's dive into Wireshark without any further delay. So this is a Wireshark. If you open a Wireshark, this is the head uh, home page of your Wireshark. As you can see, this there is some. It is same as the Windows. Like there is files, and which you can open the files that we have previously saved captured packets that you can open with this file command. You can say open. You can import from the hex term, export packets, de- dissensions, and all these things that we can do. And then there is edit, view, go. We don't have to go or dig deep into uh, all these options, but what we have to see is on this home screen. As you can see, these are all the available connection inside your PC or your computer or we can say in computer network we can say host. So here I am not connected with any Wi-Fi. As you can see here right now, I am connected with the Ethernet, unidentified network. This is the symbol of the Ethernet. That's why it is showing me that the Ethernet is connected. And you can see here it is the traffic of a Ethernet. You see the bar is going up and down. That's why the meaning of it is I am sending and receiving the data. It's on Ethernet. This is Wi-Fi. The data rate of sending and receiving is zero. These are all the logical connection that has been established into my PC. So first, what we are going to do is we are going to capture all the Ethernet data, and I will show you what kind of package it is able to capture. So if I directly click on the Ethernet, if I double click on it, you see it is a live traffic of my network. The packets that which I am sending and receiving, all the data I can see over here. And you see, if I click on this one, what is so reset current capture. So if I press this one, it will it will ask me that whether I want to save the previous packets or not. Right now, I don't want to reset my captures. What I want to do is I will stop my captures over here. So what I will get is the moment I press that Ethernet label till I press this red button stop. This is all the data packets that I have been sent on or received on my network. Are you getting my point? This is all the traffic. This is all the traffic that I have been, sending and receiving between that time. You can see here, and it is showing me all the details of all the data that I have been sent and received. This is source. This is destination. It will show you which protocol that data is related to. Length is a byte. Length is always in byte. What is the length of the data, and this is the information of that specific package. So let's say I will go up, and this is address resolution protocol. So what it is trying to do is it is trying to find the address into my network. So you see who has 224.0.0.251. And if anyone has this IP address, then reply or tell or acknowledge it to the 10.243.180.17. You see here it is standard query response with the protocol type MDNS. So what main thing I want to show is here you can see this line. We can apply filters over here. So filter meaning if I want to get a specific kind of packages, I can just write TCP and give us enter. This will give me all the TCP package into captured file or captured data. Until now, what the data that I have captured, it will show me all the TCP packages that I have sent and received. So you can see over here, let's look at any one TCP package. You see over here that this is the red TCP package, then there is a blue one, then there is a gray one. Let's say, let's look at the red one first. Okay, so here it is over 0. So this will give me all the information related to this TCP package. You see over here the frame is 11103. This is a frame number. This is 74 bytes on wire. The number of bytes that I have been sending. Okay, this is showing me that. Then there is interface on the device. It is my MAC address. Okay, interface ID it is 0. My MAC address. Then there is approach time. I'm sorry. This is a frame number. Same as this frame number. Captured length is 74. Frame length is 74 bytes. Protocol in frame. Which protocol that we have been using? It is TCP protocol. Of course, that we have seen in TCP protocol. Then let's look at the another information. It is related to Ethernet to source. Source is my PC or my laptop that I am using right now. And here it is the destination. For destination, it is showing me the IP of a TP link, my router, and the source is my own PC, and it is showing me what is the type of IP version. Then here it is interface protocol IP version 6. This is all the payload length. What is the payload related or attached with that IP version 6 package? Then hop limit. Hop limit means 128. It will take 128 hops. After 128 hop, it will discard the package. So you don't want some packages into your traffic or into your network forever. It will create unnecessary traffic. That's why the hop count is necessary. This is the MAC address of a source and destination address, MAC address of a destination. And this is a detailed, more details about TCP control. Destination port is over here. Source port is 80. Destination port number are defined due to which to distinguish between the type or which kind of data that we are using. If I am using YouTube and playing music in the background at the same time, I will receive a packages related to YouTube and my player. I'm talking about a audio player. I will receive a data at the same time, but depending on the port number, I will distinguish for which kind of application my data is related to. Then here it is showing that sequence number, then there is the acknowledgement number. When we are sending a TCP request, there is an acknowledgement in reply. That is all the data that you can see over here. This is sequence and acknowledgement analysis. It is showing this is the acknowledgement to the segment in frame 11102, and it took 5200 seconds, 0.0. It is showing it into the milliseconds. And IRRT means round trip time. We have seen in networks delays and throughput, we have seen what is RRT. It is a round trip time. It means I am sending a package from one place to another, and time it will take to send a package and receive an acknowledgement. That is called the time round trip time. So this was the TCP package. As like this, there are so many packages, and when I click on over here, this is all the data that is showing related to that TCP package. Right now it is garbage data because TCP, it is only sending a request and acknowledgement. That's all. I am not sending any data with it. This is only for the establishment, connection establishment purpose. So with that, it will only send me the garbage data. That's all. So in the next time or in the next lecture, what we will see is we will try to access one website, and depending on that website, we will filter out the TCP packages related to that website, and then we will see what kind of data we have sent to connect to that website. That's all. That's all for this video. Until we are going to see the next time.